Well, let's go ahead and get started. I'll do a quick intro and then I will turn it over to the main event. My name is Matt Lassiter and I'm the founder of Engaged Agility, and we're super excited to be able to co-host this webinar with Scaled Agile, the makers of SAFe. We have on the call today with us Harry, who is a SAFe methodologist and a SAFe fellow at Scaled Agile. And then Brian is one of our very own Engaged Agility SPCTs. Both of them have extensive experience with hardware and have seen hardware using agile principles, and they've seen it work and they've seen where it maybe didn't work so well. And they're going to tell us some of their stories today and some of the patterns that we look for as we're working with hardware teams to hopefully help them improve. With that, I'll turn it over to you guys. I'm going to turn my camera off and enjoy the webinar.
All right. Thank you, Matt. Thank you. So get kicked off here, y'all. Let's level set what to expect here in this conversation, this webinar. So to start off, we're going to start with why, right? Why is hardware agility so important today? And I think a lot of us know the answer to that. Hardware really is the foundation of everything we do, right? You can have the best AI in the world, you can have the best software in the world, but if your hardware can't run it, it's a moot point. And so we are going to touch on some of the challenges that organizations have nowadays. And the bullet point here is that, hey, hope is not a strategy anymore, right? That big design up front where we do a lot of specifications early on based off of assumptions, that is no longer really meeting the need. And so we're going to talk about how that changes and how we adjust that. And we're going to do that through the lens of these three different pillars. We're going to start off with the economics of innovation here, which is basically just telling us if it doesn't make dollars, it doesn't make sense. And so we're going to look at the economics of innovation in the hardware space, moving from manufacturing costs to the cost of change or the cost of delay. We're then going to dig into the safety piece, the governance and compliance piece. So we're going to see, well, how do we make it so that, verification of validation is not just a big batch approach at the end? How do we make sure that we can have a continuous flow of value while still maintaining our regulatory requirements? And then finally here, we're going to look at how we enable that, which is through incremental specifications here. So how do we build these massive cyber physical systems that are super complex without locking ourselves into a single point solution early on? And so we're going to start off here with, well, what is the challenge exactly that we see today? And the main challenge we see is the fact that, hey, we're making a ton of assumptions early on, right? We may spend a year, 18 months, even 2 years designing a system based off assumptions we made on day number one. That's a really common thing to see. The challenge is we need to test those assumptions. We need to see were we correct or were we incorrect. And if we have this traditional approach, yes, we're getting feedback, but it takes a long time to get feedback because we have these phase gates, we have all these documents that have to be filled out. So it takes a long time for us to understand, was that the right specification? Was that the right design, right? Can the manufacturing floor actually handle what we're trying to do? And so it takes a long time to get feedback. And so this is the standard approach that we see here. And this is one of the easiest ways to lose market share today in 2026 is by having these long lead times. And so the idea would be we want to shift away from this traditional approach where we get only a little bit of feedback over long periods of time to a more incremental approach. And so we want to move to a feedback-based way of working, where now we're no longer spending 2 years, 3 years, whatever it may be, trying to get everything perfect from the start. We are going to create a hypothesis, test it, and say, hey, is this going the right direction or not? Some of the things that getting this feedback does for us is it helps us make sure that we're building the right thing at the right time for the right reasons. That's one of the biggest things is we have an assumption that this customer is going to want this or that these components will work in a certain way. But until we validate that, we just don't know. And so this is going to provide an opportunity for us to detect problems early, right? And say, hey, that piece, that metal that we use, we may need to move from steel to titanium, right? We can make decisions like that faster because we are getting feedback so quickly. It also allows us to build a better product overall. To say that, hey, the product is actually going to meet the need for the customer. It's going to be a better fit for the customer. Harry, do you have anything to add to that?
No, yes, you said perfectly. And then on the next slide, like you said, how do we do that in hardware, right? We've been talking about faster feedback loops for quite some time in the software space. But really, digital disruption is now hitting the hardware space, right? And so we're seeing a lot more learning in the digital environment. For example, General Motors, I tell the story a lot, but they released the Hummer EV in just 2 short years. Historically, most automotive companies, they take 6 or 7 years for a brand new vehicle to come to market. And they credit the fact that they had already had a bunch of digital engineering infrastructure in place. So they did a lot of learning in the digital environment, and they were able to actually produce a vehicle by skipping some of their physical milestones along the way. But it's not just the physical, it's not just the digital environment. There's also digital hardware development with rapid prototyping and 3D printing and roboforming and CNC machines and those things. We can produce hardware much more quickly. Then we move over to a mass production environment, the manufacturing environment. There's digital technologies there. There also, we'll talk later about how they're able quickly reconfiguring the manufacturing environment to offer flexibility and be able to switch between products much more quickly. We don't have to shut the factory down for a whole week or 2 weeks to upgrade to the next model year, right? If we have a change in a vehicle, why do we batch up all those changes for 1 year and make all those changes at the end of the year? Why can't we take the change and get the next car out the door instead of the next model year? And last but not least, we want to get those changes into the operational environment. So we see instead of one big, as Brian talked about, one big 2 year feedback loop, we're getting much faster feedback, even on a daily basis, digital environment, or weekly basis as we can do things in a rapid prototyping environment. Great.
Yeah, this
Let's go. Anything
go
to
ahead.
add? Want to go next slide?
Oh, next slide. All right. Yeah, let's go
Yeah,
to
let's
the
move.
economics. This is our first
Yeah,
pillar.
let's talk about the economics. So let's talk about the economics of innovation. We want to focus on, and these are actually new slides we're adding to the hard. By the way, most of the material here you're seeing, actually all of it really comes from the Safer Hardware course, which we're going to talk about at the end. This is new material we're adding. We've had the Safer Hardware course out now for about a year, a little less than a year. And the feedback we've gotten is we talk a lot about the engineering or research and development side, the R&D side, but less about how you get those changes into manufacturing, right? So we don't want to do those big batches into manufacturing like we talked about. So I want to talk about what's the economics then of building the product along with the factory, right? Because the factory is a product too. So let's look at those the rapid prototyping technologies and mass production technologies and talk about how we can get better economics. Next slide, please. So as we know as hardware engineers, there is, custom manufacture rapid prototyping technology. CNC machines have been out for a while. They're subtractive. But you can give a digital model to a CNC machine and it can make a part for you very quickly. Likewise, with the new technologies in 3D printing, roboforming for sheet metal, there's a bunch of digital technology that allow us to produce physical parts very quickly and learn from those physical parts. Usually these are experiments in most organizations. It's not part of the regular engineering flow. What we're seeing in some organizations, particularly Tesla and SpaceX, kind of the Musk type companies, but other companies doing this as well, is instead of experimenting in R&D and then throwing it over the wall to the factory, they're evolving the factory as we go. Well, eventually, when we move to mass production, we need die casting, injection molding, right, stamping and pressing, because those things allow us to do things much more quickly, right? They have much higher upfront costs and longer lead times. But the challenge is then when you commit to these die casting with these molds, it becomes very expensive to change. It becomes hard to innovate the product. So what we're seeing now is organizations are really building the factory along with the product, right? So next slide, please. So we're not just evolving the solution, the vehicle, we're also evolving the factory to support the solution. And we really have to take a design thinking approach, right? The factory is a product, right? And we're going to evolve that like a product. It requires design thinking and feedback loops and continuous change. Are we designing and optimizing the factory to be able to change? As an example, I cite the automotive space a lot because I spent quite a bit of time there. But most automotive organizations, as we mentioned, they don't make any changes to the manufacturing line. They want it to be stable. They don't want to change it. Kind of like the operation environment we had in software 20 years ago. Once we produce things into production, don't touch it, don't change it, right? Instead, organizations like Tesla, they make 20 changes per manufacturing line on average every week, right? They're making small incremental changes. If there's an economic change, we can make a heat pump cheaper, or it draws less current in our electric car. Why would we wait a year to get that change into the vehicle instead of getting that change in the next car off the line, right? So they think differently about the manufacturing line, and they don't try to optimize it just for unit costs or just for just those types of things. So really, there's better economics in being able to design the manufacturing line to be able to support it. how do we involve our suppliers, right? Most organizations like this, it's not just our products we build, but we build and integrate components from our suppliers as well. How do they manufacture, right? So a lot of agility that we describe in the hardware course, we also talk about making sure your suppliers also support that agility. Had a story where we have one of our customers is Bosch, and they talked about this at one of our summits that Tesla actually came to them. They did the front, it was the front end of the vehicles, and they were a supplier to Tesla. And Tesla came to them and said, "We're going to give you a spec for the front end, but we're also going to give you data we're collecting from that front end. We're going to expect you to be able to make those changes and change your manufacturing line." And Bosch guy initially pushed back at that and said, "Well, we don't change everything except for one or every 2 years." But then they actually talked to their F1 organization, the Formula One organization, because the Formula One organization, they're used to changing that quickly. They change they'll change the front end in the middle of a race, those types of things. And so they were able to actually take some of those practices and those techniques. They brought that into their commercial side as well. And were able to support that. So that was a really cool story about doing innovation and not being driven just by a spec up front. All right, next slide, please. And really, what the factory of the future is going to look like. A digital factory floor is going to replace the markings, right? You've ever been in a manufacturing plant, right? There's markings where the machine equipment are set. We really want to be able to make the factory as agile as our engineering side as well, right? Because all the engineering changes we can make, it doesn't matter unless we actually get the factory to be able to apply those changes to get the product out the door. So instead of conveyor belts, we have automated guide vehicles moving things around. We do automated testing at every station, right? Tesla's pretty famous for that. Every car out the door at Tesla can be different because they make 20 changes. They make 20 changes a week on average. So at every station, there's automated tests to make sure that something hasn't broken. And they also branch the line, right? The great example there is the GigaPress. Probably most people have heard of the GigaPress, where Tesla was able to take, they reduced 70 parts that they had to integrate and weld and connect into one big stamp, right? One big form. Well, the normal, they make those kind of changes on the line, right? On the actual manufacturing line. Most of the cars are going through that 70-step process, and they take one car and they branch it and they make it the GigaPress car. And then they do the automated testing at the end of GigaPress, say, "Yep, that passed all the tests." Put that back in the line to go to the next step in the manufacturing line. And then they take the next car in the GigaPress and the next car. And eventually the GigaPress is moving as fast as those other 70 steps. So they just make that the normal line, right? So they're able to actually take those engineering changes because they've designed the manufacturing plant to be agile as well, right? And that's really kind of the next step, if you will, as we look at the hardware agility side. We also want the manufacturing to be agile as well, to be able to get the economic benefits out the door into the operational environment.
Awesome. Thank you, Harry.
Thanks.
And so that was getting into the economics of hardware agility. And another key piece there, Harry was mentioning just now, hey, it's not just the developers, the testers, the folks building the software. It's also the folks on the manufacturing floor and the operational environment, but it's also our folks that are helping validate our solution, helping certify the solution and make sure that it's working the way it is supposed to. And so agile hardware, it's not about skipping paperwork. It's about making the paperwork a byproduct of the way we work. And the way that we do this oftentimes is by building compliance runways. And so we want to make sure that by the time we do get to that final certification phase, that final verification phase, it's a non-event. We already have the paperwork, right? It's just something that was built as we were building our solution and as we were building our factory, that we have the compliance built in as well. And so that's what this piece right here is going to be all about, the compliance and governance. And the way that we often do that in an agile world is moving away from a traditional quality management system that has a lot of phase gates towards a lean quality management system. And so a lean QMS here, as you can see, these are the different practices that an organization will do right here to be able to make their quality management system more incremental in its approach. And one of the key things that we do with that is we're not just organizing around the flow of value. We're also organizing for compliance, for regulatory concern, for documentation, you name it. We're getting all of those people and all of those functions built into the Agile teams as well. And so this is what it looks like for a lean quality management system. And this next slide shows the dichotomy here between a traditional waterfall approach at the top, that long long lead time, 18 months, 2 years, 3 years, whatever it may be, where, hey, at the end of every one of these steps, all we have is some paperwork. That's all we have. We haven't actually seen the solution. It hasn't necessarily been integrated. We just have documents telling us this is what it's supposed to do, right? And this is how it's designed. But we don't actually see the solution. So we don't know if that's true or not. And so instead, we want to move to this more incremental approach here, a lean, agile way of working, where compliance is now part of our way of working. Compliance is brought into our teams. Compliance is brought into the arts. We are automating compliance where we can. And so this bottom approach here, this is really where we're trying to go toward whenever we are talking about building compliance in. Is they're just part of the team. They're just part of the Agile release train, just like any other member. Now, what this looks like in action is something like this. And so, yes, we do need the people from the hardware space, product, and the business to be on our team of teams, but we also need these other functions of the organization. We need our folks from QA, we need our folks from verification and validation, compliance, safety, security, physical security, and cybersecurity. They are now part of our team of teams or Agile release train as well.
Yeah, and that's critical. They if we're going to be building the system incrementally, we have the opportunity, right? We don't have to wait till the end to do all the compliance activities. We can do it incrementally. That's usually new for these parts of the organization, and you may not have the authority to go in and say, "Hey, you regulatory people, we need you to be, meeting with us more continuously." So there's usually some socializing of the importance of it, and you also bump into capacity problems, right? The people that actually certify or approve things maybe don't have the capacity to do that or the time. So those are things you have to address within the organization. Anytime we adopt Agile, we keep bumping into the next bottleneck as we know from a lean perspective. And those people become the bottleneck as we move into compliance, right? The people that can actually approve and things. And then you can often find ways to automate these things, right? Can we automate approvals, right? Is there certain things that you want to check? We'll build all your checks in for you automatically, and then if we pass all those checks, then great. You don't have to sign off on something. There's some things that, from a regulatory perspective, require a person to sign off on. But a lot of times, a lot of those things where they have to be physically inspected or we have to do things a certain way is really just embedded in the company culture and not really prescribed by the regulatory bodies. So those are conversations you just have to have within the organization to get those people on board.
Yeah, that's a great call out. And with a team like this too, you may have 100 people from the hardware group on this Agile release train. You might only need 2 people from security, right? You may not need a ton of folks, or you may need 15, 20 people. Really does depend on the product you're building.
Yeah, and full time, right? And maybe they're a shared service, as we call them in SAFe, right? They support us when we need us. But they come to PI planning, they come in with the teams, they see when they're going to be needed, right? And they participate and commit to the next increment, just like everybody else on the art.
Spot on. And so as we're bringing them in, we oftentimes have an opportunity here to do what Harry mentioned before, what I mentioned just a moment ago too, which is, hey, let's automate these compliance checks. Right? Let's not just test the functionality and test the performance of the solution. Let's also have checks built in for compliance to make sure that we are following things like Sarbanes-Oxley compliance, if you have that, or fiduciary compliance concerns, gap compliance, things like that. Build that into the system in the way that we're working, and then we can automate those checks, just like we do with our tests. The next thing we're going to look at here is we touched on automated testing. And whenever we're looking at a traditional approach, this inverted pyramid is typically what we see. We see organizations that have a lot of very large tests that are happening. We just got done with our design. Now we need to go ahead and test this design out multiple ways. And it can take weeks or even months to do that. It takes a lot of time, it's complex, and it is expensive. That's the traditional approach. Well, we actually want to flip this on its head. If we are automating these tests, we want tests that can run quickly. We want tests that are cheap to run and can catch most of our problems. And so if we start building in these tests, we have a lot of small tests that are going to catch the majority of the mistakes and issues that we have. And so that's going to help us ensure quality. It's going to help us ensure that we do have different compliance concerns being met. And then as we scale up and we have this agile testing pyramid, yes, we still have some large tests, like maybe UI testing, things like that still may be manual, but there's far fewer and it's far cheaper to do that because we have this foundation under it of all these automated tests.
And that requires investment, especially in the hardware space, right? And we talked about manufacturing, right? When I mentioned the GigaPress, that at the end of that GigaPress, there was a test that was run to make sure that it was still that part was leaving that station and still met compliance. Well, that robot that's doing those tests, right? Maybe with lasers or something to validate, whatever tolerances and whatnot. That's an investment, right? But the benefit of the testing is it gives us agility to be able to make changes reliably that we didn't break something, right? So the fact that some manufacturing organizations they do testing across every station, that gives us the ability to go in and be more agile and make those kinds of changes.
And the final part of this here is we want to make it build our lean quality management system in such a way that we are continuously doing our verification and validation activities. It's not a big bang approach. It's not just happening at the end of a segment or at the end of one of our phase gates. It is happening continuously. And a lot of times we use things like definitions of done. We include these different checks and these different requirements being met in our definition of done at the story level, the feature level, possibly even the epic level, depending on what you're doing. And this is a fantastic way to ensure that we're not just holding off until the very end.
That's a good point too. We talked about automated testing, right? There's certain things we can automate, right? And for regulatory compliance, but there's some things we can't, right? There still has to be sign-offs. There still has to be formal reviews. But as Brian said, let's not batch those up into a big batch reviews at the end. Let's do those incrementally, right? Shift that left as far as we can. In fact, I have a true story from an avionics company. In fact, I saw Carl's comment about compliance is not very incremental in my enterprise. I was teaching, this is a decade ago, but I was teaching a leading safe class for an avionics company. And I had the quality, the guy that ran quality at that company was in the leading safe class. It was great because we weren't just getting the engineering folks in the room, we were also getting the certification and quality people in the room to be able to sign off on DoD standards and whatnot. But he told a story in the class where they were late to pull him into some group down in Florida. And when he got there, he looked at their code reviews and they had done their reviews improperly. So the product was fine, right? The solution passed all its tests, but the objective evidence, that regulatory evidence, it wasn't satisfactory. So they had to go back and redo a bunch of code reviews. So that's one advantage to bringing those regulatory people in early and doing these kind of sign-offs incrementally. It's feedback on, are you even doing the reviews properly? And there's a story where they had to go back and redo. The product was great, but the objective evidence was wrong. We have to go back and redo it.
Yeah, one of the worst things that we can see whenever we're doing this is that we have an exciting review, because if it's exciting, that means something probably was not quite correct, right? We want these to be mundane. We want them to be boring. We want them just to be, hey, we already know it's going to work well because we have been incrementally validating this throughout. And so that's our second pillar here. And this is the last pillar here. So saying, well, how do we actually do this? And so this is going to be from an engineering perspective here, how we can define a system without locking in early. And so we often treat specifications like they're written in stone. In complex systems, though, a specification in reality is just a hypothesis statement. That's all it is, saying that, hey, there are unknowns that we need to test and validate so that we can move forward. And so we're going to look at how do we move from this big bang approach with specifications to a more incremental approach where we define the what while giving our engineers the room to discover the how. Aaron, do you want to take this first part here?
Yeah, sure. So a lot of people have seen the code of uncertainty. Maybe some folks haven't. But what it describes is the uncertainty in the system you build. And it's kind of obvious, right? So if you look at the left, on the left side of the code of uncertainty, it's the widest, right? So when we begin a product development or project, we know the least about that product in the beginning. And then as we start building it and integrating things and maybe getting feedback from users and technology, we learn things, right? And eventually, by the time we release the product, we know hopefully we know everything about it because we're about to release the product. And I love this cone of uncertainty because I always ask when I show it, where do you commit to most of your requirements and design decisions? Is it when you know the least about the product in the beginning of the cone of uncertainty, or the most about the product when you know the most about it? And all of a sudden, light bulbs go off in people's head. It's like, oh my gosh, you're right. I know nothing, but I'm making all these commitments about capacity and markets and technologies. And as Brian said, it's a bunch of assumptions, right? And then we hand those specifications off to engineers. And of course, the system engineers that wrote those specifications are on to the next specification they have to write. They're not there to answer questions and make adjustments. And people are just left with these things to figure it out. That's the wrong model, right? That works great if we're going to build something we know, right? So this type of approach, specifying up front, works great if we're going to build a house, right? We built many houses before. It's a 4-bedroom house. It's going to have 2 bathrooms, whatever. You can usually be pretty confident that there's not a lot of variability in the house we're building. However, the systems we build today, even in hardware systems, have a lot of unknown and a lot of uncertainty. And the only way to drive out uncertainty is to build something and learn, right? You can't specify your way out of uncertainty. You can't add more detail to a requirement specification or a design specification. You have to actually go build it, get feedback, and learn, right? So that's the critical point of this cone of uncertainty.
Yeah, and this slide here is actually showing that in more detail, saying that, hey, this traditional approach here on the left-hand side, this V-shaped development practice, this is where, hey, we are doing big batch approaches and big integrations. And we have our requirements here at the very beginning, but we need to go through all of these steps. We need to go through implementation all the way up to verification and validation before we can actually learn anything. And so this is something we want to shift away from, this traditional V approach. We want to move towards a continuous flow perspective. And one of the key things that we have in a safe environment is we have something called the solution intent to help us with this. The solution intent can basically be looked at as the single source of truth for everything, future state and current state. So everything that we're planning on doing in the future potentially, and everything that is currently true about the solution today. And so that includes everything from your tests, that includes your stories, your features, that includes your certification documents. It includes the traceability is brought into that too. We use a solution intent to provide traceability to maintain compliance. And so this is the approach that we take, and that solution intent is one of the most powerful tools we have at our disposal to ensure that we are able to have a continuous flow of value instead of using this big batch approach.
Yeah, and the key is the figure on the right. The only thing I'll add is that we evolve together, right? We have a backlog of unknowns, right? A bunch of uncertainty, right? And that's the work to go gain certainty. And as we learn things, we're going to evolve the specifications while we evolve the solution. And we'll end with that, but that's the beginning of that slide on the image on the right there.
And so digging a little bit deeper into our solution intent here, these are all of the things that comprise that solution intent. And your solution intent is part of your lean quality management system. Oftentimes, this is a combination of multiple tools, multiple resources that are brought together. Oftentimes, an engineer, an architect, somebody like that is ensuring that we're maintaining it and that it's being built and that the right people have access to the right things. But this includes all of the information that we need so that we can do our verification and validation incrementally.
So certainly we need specifications, right? We need specifications for regulatory compliance. So specifications really serve many purposes, right? Some of them, they specify the system, they describe the solution, we use them for verification, validation, compliance activities. But a lot of time we go into much deeper specifications, right? So we use them to communicate what to build, right? And that's why that's that old model, right? Where we're specifying everything up front. We better specify exactly what we want this team to build and hand it off to them. Well, that doesn't allow the team really any flexibility, right? It really constrains them. They can't innovate. They can't, find better ways of providing this solution, right? So the traditional approach to having these deep hierarchies of specification is really hurting agility, right? And it doesn't allow, and furthermore, we have another place in Agile where we can put those deeper kinds of specifications.
That would be our backlog.
Exactly. Yeah. So instead in Agile, we communicate what to build by putting that in backlogs and roadmaps, right? So we don't need these detailed specs. We still need specifications, right? When you talk to your system engineers and your other folks, yes, we need specifications, but you don't have to specify everything, right? We have another place to hold that information, and it's really the specifications those backlog requirements are specified by the team with the product owner, right, at the time they're going to build it. So we don't fill our backlogs with 2 years worth of work, as we know it from an Agile perspective, like we would do with old specifications. Instead, we start with a vision and let the teams evolve their specifications, right, in the backlogs.
I'd say a good perspective on this is that the solution intent here, this top piece, this is really about the mission, what we intend for it to do, but it's not the how. Right? The how is for the teams to discover, for the teams to create, and that's what's captured in our backlogs.
Yeah. And because we know in Agile, right, the best form of communication is documents, right? And I'm kidding, right? But I say that a lot of times when I'm teaching a class just to get people's reactions. They go, yeah, you say it with a straight face like that. And it's not, right? And in fact, that's why I forgot his name, Alistair Coburn, one of the Agile Manifesto people. He has a great quote that I love. He said, "A backlog item or a story is a placeholder for a conversation." Right? And really, that's what those backlog items are for, is to have the conversation with the teams and the product owner, or the product owner, the product manager, right? If it's features and you're an agile release train, right? Those backlog items are really, they don't have a lot of detail in them. They don't have all the details. The details are fleshed out in conversation. And so in Agile, we have conversations where the old way, where we specified everything up front, we put all kind of detail, invested a lot of energy into those specifications because that was a handoff, right? Agile doesn't try to hand things off. Agile tries to pass down knowledge and information from one level to the next, right? And they do that through backlog items that are really just placeholders for a conversation. And then, and this is kind of then the summary slide, right? It's that we don't start with specifications. We start with a vision and a roadmap. We start with a vision and some release dates or some milestones, some integration points. A lot of those integration points could be Safe has built-in integration points. Every increment, we're integrating the end-to-end system. What are we going to get this next increment? What are we going to get this next increment? So that PI roadmap of, the next increment, we're going to see something, then the increment after that, we're going to see something more, and the increment after that, we're going to see something more. Those are integration points that are pull events to try to get all the engineers, right, to say, okay, I know you're working on designs and whatnot, but let's integrate. That integration in hardware might be a digital model, might be a digital integration, or they might be mock-ups, as we talked about in the manufacturing side. They might be a 3D printed part or some kind of wood substitute or whatnot. But we're trying to integrate the system to learn things along the way. So we don't start with specifications. We start with a vision and a roadmap, and we incrementally, and the backlog is trying to answer the questions that are going to build the solution and then populate that solution intent, right? The requirements and design decisions that we make along the way, right? So it's allowed to evolve, but driven by roadmaps and vision, not by specifications.
Awesome. And with that, those were the three pillars there that we wanted to dig into regarding hardware agility here. And so if you want to learn more, well, we have a couple of classes, a couple of opportunities coming up in the near future here. We do have a Safe for Hardware class. That's one that actually, Harry, you're the main person on that one, correct?
Yes, that was a lot of fun. We have a little time to talk about it. So we built the Safer Hardware course. We were pulled into this by our community, and we had a community of probably 15 or 18 people. We met weekly every Monday, and then right before the release, we met twice a week, Monday and Wednesday, right? And hey, here's the content, give us feedback. Here's the content, give us feedback. So it was really a group effort to go build the Safer Hardware course. And the slides you see here came from that course. As I mentioned, we didn't have a manufacturing element, so you're the first people to see those manufacturing slides, right? We're going to integrate those sometime for release, probably the next couple months. And we have a Safer Hardware course, which is if you're a safe organization, you think of leading safe, right? Well, it's hard to get your hardware folks to go to leading safe because there's so much kind of software in it. So this is really Safer Hardware is like the leading safe for your managers and your directors and your practitioners that are going to lead hardware type activities. And instead of talking about portfolio and those types of things, it talks about the topics we just talked about here. And then when you're launching an ART, another challenge with the Safer Teams course is that it was also filled with a bunch of software examples and software concerns that, if you ever launched an ART before and tried to teach Safer Teams, the hardware people kind of check out for that. And they go, that we told you this agile stuff was for software people. It's not for us. Well, we fixed that, right? And so we made a variant of Safer Teams. It's same pedagogy, same structure, but we added, well, not quite the same structure. There's a couple modules we did make changes to talk about hardware concerns. But the general things about what's a story, what's an art, why we do an art, is the same. But it's filled with hardware examples and hardware concerns. So but we kept some software in there too. So if you have an art that's mixed with software and hardware, right, that's the course you want to teach. So it addresses both hardware and software.
I had a question there in chat about solution intent and what does that actually look like?
Yes, that's the next part right here, Q&A.
Hey, Matt, perfect timing.
Perfect.
Yeah, so what's the solution intent look like? It depends on the organization. It might look like, hey, can you back up to that slide? It was let me look at it.
Yeah.
21.
Slide 21, sure thing.
So before I joined Scaled Agile, I spent some time at a company. We were an IBM Rational Business Partner, and so we helped organizations adopt, agile practices, but also, they had to be regulatory compliance and certification using tools like uh, Rhapsody for modeling or Doors for requirements management. A lot of organizations probably have seen those types of requirements management tools. And this is 10 or 15 years ago. So what's your requirements model look like? There are tools out there to support those. As again, I was IBM Rational Partner, and we help organizations adopt Doors and Doors Next Gen. So that's how you manage your requirements model, and they evolve requirements. But those have to trace then sometimes to a solution. Where's this requirement implemented in your solution, right? Traceability between those things. So it could be formal tools that you use. We sold Rhapsody and Doors and those types of products. But it could just be SharePoint too. It could be just documents or spreadsheets that you're managing and maintaining in like a SharePoint environment. So it really depends on your organization and how you manage those things. But the goal is to keep the information that you have to in there, right? That was cool about, with Doors back then, because Doors could trace to agile planning tools, right? So you could say, hey, this requirement's being implemented by that feature, right? So you had that kind of traceability. So your requirements model is the things you need to manage for regulatory and be able to generate the artifacts and documents that they need, the objective evidence that we can produce a solution. And then test models. There's tools out there to support these things, but it also could be just, as I said, SharePoint or documents in a document repository that are connected and linked, and you've got your own practices for being able to produce that quality management system, being able to produce the documents you need to support the regulatory compliance activities.
Yeah, a lot of times I've either seen a custom tool built by an enterprise for this explicitly,
Yeah.
or I have seen folks that really just piece it together with the other tools they have, and then they'll have something like, for example, they'll build a Google site around a solution, and they'll say, hey, anything for compliance or documentation, here's the site you go to, right? It'll just be a series of links basically that get you to the actual documentation, that get you to the actual backlogs, that get you to the actual design documents, that get you to the legal documents, all of those things. And so it really does depend on the organization you're with. A lot of them I see will have either a Confluence page, Jira pages, they'll have SharePoint. Those are going to be components of the overall solution intent. And usually you do need somebody managing this. This is not something that typically will form naturally. And so if you don't have somebody managing this, usually an architect or an engineer, this traceability goes by the wayside. And that's one of the key benefits of having a solution intent is that you do have that traceability for verification and validation purposes, making sure that we're compliant with legal concerns, things like that.
Yeah, that's a great point, Brian. Somebody has to own it. They don't populate it, right? As we showed at the end, right? That the content in that solution intent is going to evolve, right? We're not going to start with a requirements model with a detailed requirement spec. But as we make decisions, we're going to document those decisions as a requirement, right? Because we have to say we finalized this requirement. For example, what's the range of the vehicle when we start? I don't know. The range will be determined by, we can decide that later. But maybe that is a requirement we have to meet for some requirement, or maybe some requirement for our customer. When we make that decision, it will evolve and go into that requirements model, but somebody has to manage it and make sure that we know where that information is going to go and how it's going to be traced to the other parts of those other models as well.
That it stays up to date, because these can go out of date very quickly, and that can lead to some challenges.
Hey guys, one thing that I want to make a comment here, just because I've seen it happening in the past, and I guess I can turn on my video here for a second. This idea of the variable and fixed, the little tag that sits above the solution intent model, I think it's important. It shows the cone of uncertainty almost, laid right over this idea of solution intent, saying that there's a lot we don't know in the beginning, and there's a lot of variability built in. And as we mature and iterate on this solution, then things become more and more fixed, and we're just documenting the variability or the fixedness through this idea of the solution intent documentation that we're talking about.
Yeah, Matt, that's a great point. In fact, we discussed that in the course, in the hardware course. There's a section where we talk about how you specify something. And I mentioned, just as one example, what's the range? We have a new vehicle. What's the range of that vehicle going to be? Well, we don't want to fix it and say it's going to be 200 miles or 450
Mhm.
kilometers up front. We want to give the intent to the teams. Well, our intent is to go to these regions. And we want to be able to market the car, and it's for local deliveries of things, right? And that the team will figure out what the range needs to be, right? And then eventually, so we give the intent to the teams about how we're purposing this vehicle, who the target market is, and then they'll explore and figure out through empathy and design thinking what the right range is going to be. And when they make that decision, then it goes into the model. So there will be a range, but giving the intent to the team allows them to later on move from variable towards fixed. It does become fixed by the end, but doesn't start fixed, to your point.
We also
Now,
have a question out in chat. Janina asked, how do you address the need for a functional system model to help the teams understand the integration of various system components
Yeah.
and enable their design?
So we strongly believe in intentional architecture and emergent design, right? So to your point, there needs to be, we can't just say teams go build your parts, right? We're gonna have to integrate this into a system eventually, right? So there is an intentional architecture. We have system architects that specify those things. And so that when we do integrate this thing, it will work. But we also want to make sure that intentional architecture doesn't over constrain the team so they can incrementally evolve their designs. Again, we talk about this in the course. We talk about, designing systems and managing interfaces between those components so the teams can iteratively evolve their designs. And then we can at those integration points, every increment, we want to ideally be taking as many of the new versions of the components of the system and be integrating with what we can, right? And sometimes those integrations in hardware are in digital models. Sometimes they might be 3D printed. And I remember this is, gosh, one of my first safety implementations was actually at a hardware company back almost 15 years ago, 12 years ago. And I remember at the end of the first PI, the teams all got excited because they actually had 3D printed some certain parts and found out they weren't going to connect together. And they were excited because they learned that in 3 months instead of 15 months where they would have caught it downstream, right? That was kind of when 3D printing was kind of the early kind of cool thing. But the point is we want to do those kind of integrations, right? So there was an intentional architecture that said, yeah, these two components are supposed to fit together, and we manage the interfaces between them. But we also don't want to overconstrain the teams, allow them to iteratively evolve their design, and then check that and then have integration points where we do check those things. And in safe, that's every increment if we can.
awesome. Any other questions y'all have?
Yeah, we just got one.
Yep,
Somebody
I know.
said, John asked, are there AI implications? Absolutely.
Yes.
Let's go back to slide.
3D modeling at the start.
Yeah, I would go back. Let's go back to slide 5. Yeah,
Yep,
exactly.
I'm right there with you.
Yeah.
Yeah, I'm right there with you.
So, John, you bring up a great point, and we need to add this to the class, right? This is also on the backlog. We are getting the manufacturing in first, but is AI disruptive? Absolutely. But we have unique possibilities to take advantage of AI because all of our data in hardware is already in some kind of representation where we can leverage it, right? We have a bunch of digital models. We have a bunch of rapid prototyping environments. And really, there's another slide that's in the course, but out of every one of these environments, we should be collecting all the data from the digital environments, from the manufacturing environments, from the rapid prototyping, and the operational environments, and make that one big kind of digital shadow, digital twin kind of, and that's going to tell us all kind of things. Where can we improve our manufacturing processes? Where can we improve the product? So where can we improve our engineering practices? And we need to leverage AI to help us drive those things. So yes, is AI going to help? Implications of AI will be dramatic. And organizations that don't already have the ability to capture all this data, because AI is always driven by data, right? AI is only as good as the data that you're gonna put into it. And some organizations are very good at collecting all this data in one kind of integrated environment. Others, the operational data is with the operational people, and the manufacturing data is with manufacturing people, and the engineering data is with engineering people, and they don't have a big view of this. In fact, this is an interesting story. Since we got a couple minutes, I'll tell it. Back when SAFe did we did AI, big data, and cloud. We added that to the SAFe framework like 5 years ago because we kind of saw AI coming. And so I was responsible for doing the big data stuff, right? So I went and interviewed a bunch of companies about big data, and they talked about, oh yeah, we got a bunch of siloed data, and we're integrating that into this data warehouse, and we're gonna, it's a data is a product that we distribute to other folks. I talked with the lead data science person at Facebook. A friend of mine pulled me, and he knows him. And so he manages, like, at the time there were like 300 or 400 data scientists at Facebook, or at Facebook. It was foreign to him to think about the fact they'd have to integrate their data. Since Facebook was grown natively, right? When the sales data, the performance data, the user data, it was all already in one big data model, right? They just grown out Facebook that way to begin with. You could do a SQL query on all the data, right? So some organizations are natively that way, some aren't. But if you haven't started a data strategy to try to integrate this data, there are many hardware organizations that already do that today, and you probably need to start because AI will change how we design and integrate things. Another quick story I'll tell, Mentor Graphics. So a colleague of mine I knew from the Incosi group ran the Mentor Graphics engineering group, and he told me that they have a bunch of the data that they collect from all the designs, right? The manufacturing design layout, manufacturing plants from down to physical parts. And they have all this data, and they could make, when I'm designing a part, I could say, okay, this part's for this purpose, help me design it, right? And AI could actually design the parts for you. But they don't have the copyright, intellectual property rights to be able to feed that data into AI, right? So there are organizations that are doing this within the organizations. Is we have a bunch of like heat pumps in all our vehicles. Let's feed that into AI and say, great, how can I improve these? How can I improve these different models, right? And again, the more data that we have across these different kinds of designs that we've done in the past, the better that AI is going to be able to help us and guide us in that direction. So anyway, yeah, a lot of conversations about AI. It's definitely coming down the pipe, and we need to prepare for it.
I'd say AI is built into a lot of the strategies for all of these different aspects of the digital environment here. You're starting to see companies use AI to help them do 3D modeling for the prototyping, right? To do the design for new products, new components, things like that. You're starting to see the digital shadows here. You're starting to see the data from the manufacturing environment go back to a digital shadow so that we can actually capture data, so that we can actually feed it into an AI to give us opportunities or issues that we can fix on the manufacturing floor. And then you're starting to see digital twins as well use AI, where the digital twin is actually taking a look at all the information it's getting from the operational environment, from the actual hardware being in use. And it is saying, here's how we can tweak things and adjust things to make it better in the operational environment. So AI is currently being built into every one of those aspects.
Guys, we have one more question out there from Janina. She wants to know if we have any practical advice for work breakdown because hardware teams usually struggle with that aspect.
Usually, we give examples in the course of breaking features into stories, right? So we have an example, but it's usually domain specific. Everybody when I talk across different types of organizations, automotive, space, a medical device, it's hard for people to translate how you decompose the system, how you decompose the teams, and how you decompose the work, right? Those are always, I want to see that in my context, right? And that's what you're asking here is how do I break down the work? Usually want to see, we like I said, we have examples in the course. It's for the example, I think it's an autonomous little vehicle example. But usually they need help with this. And the best guidance I've done in the past is what do you want to be able to show at the end of the week, right? What shows progress at the end of the week, right? Right. The next milestone is coming up. It's some 2-3 months down the road. It might be the next PI. What are you going to do this week to be able to make progress towards that shows you're going to be able to make that, right? Great. That's a backlog item. Do that. Right. It might be I've got to update a model. I've got to design circuits in my board. I've got to go rev a board. So we have some examples, but it isn't a domain. But you're right. A lot of people struggle with that, and I found that usually asking the question about how you're going to demonstrate progress towards that goal usually helps them flush those ideas out.
Yeah, I've seen a lot of folks focus on individual components or parts of products and say, well, who are the different skills we need? We need somebody that knows MCAD over here. We need somebody that knows ECAD. We need somebody that knows the data aspect. And you get all those folks together. We need an engineer in here, and we get all those different skill sets together to be able to build that specific component. And then you break the work down for that team. So each team member might have a different type of work that they're focused on, right? Like one of them may be focused on the electrical CAD, one might be focused on the mechanical CAD. And so those folks will break their work down so that they can achieve the objective of the team every 2 to 3 weeks, typically.
I like to think of it sometimes that when you're breaking down work, especially in something like hardware, where your build times can be much longer, but I need to learn something in this week that will help me, to Harry's point, be more predictable about can we meet our date that's out there 2 to 3 months from now. And sometimes that learning and designing how I'm going to learn that can be super duper valuable, as opposed to I'm just going to keep cranking away building the thing, right? It's like, no, I have to learn something. And that's what I'll show at the demo. I will show what I learned, which leads me to the next decision that I need to make on the design or the interface or whatever it might be.
All right. Are there any other questions?
If there's no more questions, we'll just hang around for a couple of minutes. We really do appreciate everybody coming to the webinar. We'll hang around in case somebody has questions that they decide they want to ask. But otherwise, we really appreciate y'all's time. Brian, Harry, wonderful as usual. We really appreciate it. Y'all have a good rest of the day. And if you're in one of the cold spots, stay warm.